Alright, so if you've come to this video, then you are working on the worksheet that I've given to you guys since I am not here with you guys today. So here to help you out, I've created this video and we are going to try to solve these problems out together. Okay? So the first problem here, we're just trying to simplify. These problems, we are just simplifying the expression, so we're going to just combine like terms until we can't combine anymore. So like this here, I see a real number and another real number, so I can go ahead and combine them. Right, I can combine 4 and 7 to make positive 3, because negative 4 plus 7 is positive 3. And it looks like I have an imaginary number with another imaginary number. If I take 5i and add it with negative 5i, I get positive 2i. So it looks like my answer is 3 plus 2i. All right, now let's try this one here. So because there are parentheses, it's implying that I'm multiplying these terms out. So what I have to do is maybe multiply 2 at a time would be easiest. If I multiply these 2 at a time, I would have, let's see, 2 times negative 4 gives me negative 8, but I times I gives me I squared. But we learned that I squared is just negative 1. It's a real number. So I can really write this as negative 8 times negative 1, which gives me positive 8. Now keep in mind, next to this was a 7i, so I'm going to bring that down. So this is multiplying by 7i. So if I multiply 8 with 7i, I have 8 times 7 gives me 56i. And that is my final answer, 56i. All right, let's try some more in the next slide. Okay, so here I have some more problems where you're simplifying, and so these have more variety to it. Like this one here, you have a 2 on the outside, you have a 5i on the outside of this parentheses. So what I'm thinking is, well, since I have this number, this imaginary number outside the parentheses, I probably need to distribute that. And I know I can distribute because there's no exponent out here in the way. So I'm going to go ahead and bring down this 2. And I'm going to distribute this 5i, but keep in mind that's a negative 5i that I'm distributing. So that is going to be negative 15i, because 5 times 3 gives you 15. Negative 5i times negative 7i. Well, negative 5 times negative 7 gives me positive 35, but I times I gives me I squared. So at this point here, you want to change, like, you want to combine like terms, but what you might notice is that you have an I square, so we got to change that to a negative 1. So I'm going to replace the I square by a negative 1, and so this allows me to say that this is 2 minus 5i minus 35 if you multiply the negative 1 with the 35. And so then you have two like terms here, these two, right? 2 and negative 35 come together to make negative 33. But then you still have this I in the middle, so negative 15i comes down. And that's it. So it looks like that is my answer. Okay, so in this next problem here, I have a 3i in front of this parentheses here. So I think I just need to distribute, right? Because there's no exponent here in the way for me to distribute. So this problem is actually easier than the one before it. So if I distribute, well, 3i times negative 7 gives me negative 21i. And then 3i times positive 9i, well, that is positive 27i squared, because 3 times 9 gives you 27, I times I gives you I squared. And so from here, I'm just going to change that I squared to a negative 1. So this becomes negative 1i, negative 21i, bring that down 27 gets multiplied by a negative 1. And so I have negative 21i minus 27 if you multiply these two. Now, looking at this here, it looks like I can't combine any further because that's an imaginary number and that's a real number. So I'm done. Okay, let's try a couple more simplifying problems with the division one. All right, so in this problem here, I have a division problem. And yesterday we learned how to divide with imaginary numbers. So it turns out when you're dividing, the denominator, so the number you're dividing by, can't be imaginary, or else you can't divide with imaginary numbers. So what we have to do is get rid of that I in the denominator. So to do that, we learned something called the conjugate, right? So in order to get rid of imaginary numbers, you can multiply it by its conjugate. So the conjugate means the same expression but opposite signs. So instead of 3 plus I have to multiply the bottom by 3 minus I. So 3 minus I is the conjugate of 3 plus I. But anything I multiply to the bottom of this fraction, I need to multiply to the top of this fraction. So the top will also be 3 minus I. Okay, that's just because, anything over itself is really just a 1. So I'm really multiplying this guy by 1, which would not change the actual value. So once I proceed with this, I have to multiply everything out. So numerator with numerator, denominator with denominator. And so what I like to do when I'm setting this up is wrap parentheses around my expression. So I'm going to put parentheses around the 3 minus I, bring the 6i over, and I'll multiply that here in a minute. And I'm going to wrap parentheses around the 3 plus I and the 3 minus I. So when I'm foiling this out here on the, or distributing the one on the top, so what I'm going to do is multiply the top out and foil out the bottom. So the top here, 6i times 3 gives me 18i. 6i times negative I is negative 6i squared. And so now I'm done with the top, I'm going to FOIL out the bottom. So 3 times 3 gives me 9, 3 times I gives me negative 3i. I times 3 gives me a positive 3i, and then I times negative I is negative I squared. And so looking at the top and bottom, well, the top here, I notice that there is a I squared, so that gets replaced. So does this one here, there's another I squared. The bottom, notice how there's a negative 3i and a positive 3i, so that cancels. And so really what I have left is the top, which is 18i minus 6 times negative 1, since the I squared gets changed to a negative 1. The bottom is a 9 that gets brought down. The middle terms cancel because that's what happens when you multiply with conjugates. The middle terms cancel. And then this guy gets brought down as a, there's a negative sign, but then there's negative 1 because I squared is negative 1. And so when you simplify this just a little bit further, you have the top being 18i plus 6, and the bottom being 9 plus 1. 9 plus 1 is just 10 in the bottom, so 18i plus 6. And we mentioned this yesterday that once you have the bottom as a real number, notice how the bottom here doesn't have any i's or imaginary numbers. Well, in that case, you can stop right there and leave your answer like this. Now, in math, this would be, like in Algebra 2, this would be a perfectly fine answer. But in case you go on to pre-calculus, you might want to know how to simplify a little bit further. So if you were to further simplify this, it says that you're dividing by 10 in the bottom. So now, since it's not imaginary, you can actually divide by 10. So you take 18 and divide it by 10, and you can write that as a fraction. So you have 18 over 10i plus 6 divided by 10, which is 6 divided by 10. And so if you look at this, you can actually reduce both of these fractions. This fraction, what goes into 18 and 10? Well, let's just try 2. 2 goes into So 2 goes into 18 9 times. 2 goes into 10 5 times. If I try the other one here, 6 and 10 can be reduced because 2 goes into 6 and 10. 2 goes into 6 3 times. 2 goes into 10 5 times. And so I really have 9 over 5i plus 3 over 5. And so this here is the most simplified form. But like I said, if you don't have it in the most simplified form for imaginary numbers, it's not a big deal when you're dealing with division. But you do need to get to at least this step where there's no i's in the denominator. Okay, let's do one more of these for practice. So this problem here, I have 2 plus I over 1 minus 4i. So I'm dividing by this 1 minus 4i. And in order to do that, well, first I have to realize that's an imaginary number. I can't divide by an imaginary number in the bottom. So what I have to do is take that expression and multiply it by the conjugate. So if I multiply the bottom by the conjugate, well, the conjugate is 1 plus 4i. I just changed the signs. So I have to multiply the top by also 1 plus 4i. And so if I multiply this out, let's wrap some parentheses around here to make it a little bit easier. So the top really is 2 plus I times 1 plus 4i. And the bottom is 1 minus 4i times 1 plus 4i. And so if you're working this out, you're going to have to FOIL the top and you have to FOIL the bottom. So let's go ahead and do that. So if I FOIL the top, 2 times 1 gives me 2. 2 times 4i gives me positive 8i. I times 1 gives me 1i. I times 4i gives me positive 4i squared. And so now I'm done FOILing out the top. I can FOIL the bottom. 1 times 1 gives me 1. 1 times 4i gives me 4i. Negative 4 times negative 4i times 1 gives me negative 4i. And then negative 4i times positive 4i gives me negative 16, because negative 4 times 4 gives me negative 16. But there are two i's being multiplied, so I squared. So I'm going to simplify here now, but keep in mind the pattern is very similar to the last problem. The middle terms in the bottom cancel because you multiply by a conjugate. The middle terms are opposite signs, same coefficient. They're going to cancel. I notice that there is a I square here. So I'm going to change all those I squares to negative 1. So looking at this top part here, I have a 2 that I'm going to bring down. I also notice the middle terms here are both I, so I can combine those. 8i plus 1i gives me 9i. And then I have a 4 times a negative 1. And then the bottom is a 1 minus 16. And then it's multiplied by I, which is negative 1. So from here, I can maybe combine some like terms. So in this case, I have 2 plus 9i minus 4 over, well, 1 plus 16, because that's going to be negative 16 times 1, which is positive 16. So from here, I'm going to combine the like terms, like I have a negative 4 and a 2. So I have, what would that be? 9i minus 2 for the top. And then the bottom, 1 plus 16 gives me 17. And so from here, I can leave my answer like this, because in this case, the bottom here no longer has any i's. So no more imaginary numbers. And I can't combine these top because 9i is an imaginary number. Negative 2 is a real number. They're not like terms, so I can't combine them. And so that's all I can do. Sorry about that, guys. That was my Google timer going off. So in this problem here, this would be the final answer. You could also try to reduce the top and bottom, but I don't think this one's reducible. Let's try. So you would take the 17 and divide both terms by 17, and you can write that as a fraction. So 9 divided by 17i minus 2 over 17. Notice how like these fractions, 9 and 17, don't have anything in common to divide. Neither do 2 and 17. So this is actually the most reduced format, but it's not, you can't really reduce it any more than this here. So this here is also a perfectly fine answer. You can have either this answer or this answer. They both mean the same thing. All right, so we've done a lot of simplifying problems. Let's try some solving problems. We'll do a couple more, and that's pretty much it for this worksheet. Okay, so in this last two problems, what you have to do is solve the equation. So solving means that, well, you have to get the x by itself. So there's the x, there's the x. So solve means to get x by itself. So I gotta think about, how do I get this x by itself? Like, what do I have to remove first, right? There's a lot of stuff here. So what I recommend is to always think of when you're solving for equations like you're peeling an onion. You're taking the outer layer first and then slowly peeling towards the inner layer, right? So the outer layer of this function, or the thing that's furthest out from x, is this 12, okay? 12 is the furthest thing out. So you got to remove the 12 first. So I'm going to subtract 12, and that cancels. And so I have 3x plus 2 squared equals negative 12. Then the next thing that's further out, so notice there's a 2 next to the x, that's still very close to the x. There's a square here that would square the number next. But then the next thing out is the 3. So the 3 I need to remove, and I remove that by dividing, because that 3 is multiplying the parentheses. So if I divide, that cancels, but then I divide this side. So then x plus 2 squared drops down. Negative 12 divided by 3 gives me negative 4. And then I have to take a square root to get rid of this square. So I'm going to take a square root. So the 2 and the root cancel, bringing down the x plus 2. The square root of negative 4. So just ignore the negative for a moment. The square root of 4 is 2, right? But because there's a negative sign, that means it's an imaginary number. But because it's a square root, it has a positive and negative sign, okay? Plus and minus. So from here, I'm not done solving for x, right? I have to remove this 2. So what I like to do when I have a positive and negative is to split up the two equations so that way I can solve it easier. So I have x plus 2 equals positive 2i, and I have x plus 2 equals negative 2i. If I were to solve this, I could subtract the 2 first on that side, and so x comes down. 2i and negative 2i are not like terms, so we bring it down the way it is. So that's going to be 2i minus 2, and that's our first x value. We can do it with this one too by subtracting by 2. That cancels. X drops down. Like I said, these two are not like term because that's imaginary. That's a real number. So I'm going to bring it down the way it is. So negative 2i minus 2. And that's my x value there. Okay. So from this one here, this last one, this one's not as lengthy as the one before. But here's my x. I need to try to get the x by itself. So again, I need to move the thing that's further away from the x, which is this positive 21. To get rid of this positive 21, I need to subtract 21. That cancels. So I have 3x squared equals negative 21. Then from there, I need to remove that 3 by dividing by 3. So that cancels. So x squared is equal to negative 7, because negative 21 divided by 3 is negative 7. To get rid of a square, I take a square root. So I'm going to take the square root of both sides. Cancels. X drops down. Now the square root of 7, so just ignoring that negative for a moment, but the square root of 7 isn't a perfect square. So that means I'm going to keep it under a root. I'm going to keep the 7 under a root. But because it's a negative sign, I'm going to need an imaginary number next to this root. So I'm not going to have a negative number anymore inside the root because I'm putting this I next to it, so that's saying that it's a negative inside the root. And then because it's a square root, I need a plus and a minus because any square root has a positive sign and a negative sign. And that's it on the on those problems on the worksheet. You'll notice on the back of the worksheet, I have two challenge problems that are worth bonus. So if you try those out, show all the work, then I will give you guys 2 bonus points for that, for solving. But for the worksheet, you just have to solve the front page, which is 8 problems that I've done for you in this video. I hope you have a wonderful day. See you tomorrow.